Welcome to the DNA podcast. In this episode, we uncover whether the Sun could one day swallow Mercury, Venus, and even Earth, and what a new study reveals about the future of our solar system. The answer lies in the Sun's natural life cycle, a process that unfolds over billions of years. We can ask some existential questions about the universe that go far beyond what is possible for humans and for life on Earth in general. The Sun is an enraged ball of fire that powers life on Earth by employing nuclear physics concepts. This life-giving entity won't always be so generous, and eventually it will run out of hydrogen fuel. In almost 5 billion years, the Sun will turn into a red behemoth as its fuel runs out. It will go out for one more hunt in its neighborhood, the solar system, even though it will lose its ability to sustain life. After another 4 to 5 billion years pass, the Sun will swell into a red giant, entering the next phase of its evolution. When that happens, Mercury and Venus will definitely get swallowed. But what about the Earth? Researchers, in a study, have revealed the forces acting on a planet when it is swallowed by an expanding star. The study submitted for publication in the Royal Astronomical Journal states that interactions of a planet or brown dwarf with the hot gas in the outer envelope of a Sun-like star can lead to a range of outcomes depending on the size of the engulfed object and the stage of the star's evolution. The flow near a planet that is being engulfed by a stellar envelope was simulated in 3 dimensions by the researchers. Depending on the mass of the consumed object and the stage of the star's life, they discovered that the Sun's consumption of its planets might further enhance the luminosity of a Sun-like star by several orders of magnitude for up to several thousand years. Lead author Ricardo Yarza at the University of California, Santa Cruz explained that, as the planet travels inside the star, drag forces transfer energy from the planet to the star, and the stellar envelope can become unbound if the transferred energy exceeds its binding energy. His team did point out that it is challenging to run simulations that effectively represent the physical processes taking place at each scale because evolved stars can be hundreds or even thousands of times larger than their planets, and that no planet smaller than about 100 times the mass of Jupiter can eject out of the envelope of a Sun-like star before it has expanded to about 10 times the radius of the Sun. The study's findings can examine the future report about the impact of engulfment on the star's structure. The Sun, which has an estimated age of 4.57 billion years and is currently enjoying its middle age while fusing hydrogen into helium and generally being relatively stable, was recently disclosed by the European Space Agency. It will grow into a red giant star and drop its surface temperature when the hydrogen in its core exhausts and modifications in the fusion process take place. Thank you for tuning in to this podcast. If you enjoyed this episode, make sure to like, share, and subscribe for more captivating tales from India and beyond.